So this is a neighbor Sudoku with no given digits. I was first inspired to start messing around with this after Nathan F. posed a question in the CTC Discord if it was even possible to construct such a puzzle. And the original version had a bunch of rows where the clues outside were 1, 2, and 2, 3, which would force strings of 1, 2, 3 in them. And when you get 8 rows like that in the puzzle, it has some interesting repercussions on the columns. And I made a puzzle like that and proved that it was unique and then showed it off, and that was that. And it didn't have very interesting logic in it. But then I later revisited this idea to try and make a puzzle that actually had some substance to it, and the result of that is the puzzle you now see on screen. I think eventually it would be interesting to try and experiment and see if it's possible to do this without having any clues on the right or bottom borders, which is a little bit cheating, but not that much. But if it is possible, it would be a pretty impressive feat, and I think would make a really elegant looking grid. And if it's, human solvable and has some fun logic in it, then even better. But as for this puzzle, the break-in has to do with these 6-7 pairs that appear in columns 2, 5, and 8 and rows 2, 5, and 8. The first key insight here is to ask if a cell like this can be 6 or 7. Let's say I tried to make this a 6. Now the column clue is telling us that there has to be a 7 adjacent to it in the column, which puts a 7 in one of these two cells. And the row clue is telling us that there has to be a 7 adjacent to it in the row as well, and we end up with too many 7s in the box. So this cell can't be a 6 or 7, and neither can any of the cells where these intersect, because they all intersect in the center cell of a box. What's more, if you now look at a cell like this, and ask if it can be a 6 or a 7, well obviously no, once I make this a 6 or 7, then this has to be, and we've already established that it cannot. So actually in all of these rows and columns, there are only 2 places where I can put the 6s and 7s, forming this sort of pattern. Now if we look at the central box, this row is either going to have a 6-7 pair here, or a 6-7 pair here. And this column is either going to have a 6-7 pair here, or a 6-7 pair here. So either way, the 2 6-7 digits in box 5, one of them is going to appear in these 2 cells, and one of them is going to appear in these 2 cells, and that accounts for all the 6s and 7s in the box. Which crucially means that cells like this and this cannot be 6 or 7. And that's going to matter for this column, where we have a 1-6 and a 1-7. So in this column, the 1 has to appear between the 6 and the 7, which means that the 6s and 7s have to appear 2 cells apart, which is going to be a problem for a cell like this. If I try and make this a 6 or a 7, I can't make this the 1, so this would have to be the 1, and this would have to be a 6 or 7, which we've just established it cannot be. So I can eliminate this cell for exactly the same reason I can eliminate this cell, and in these rows now, these can't be, so I know exactly where the 6-7 pairs are appearing. These now form an X-wing, or I guess just regular pairs, eliminating 6 and 7 from these 2 cells. And that means that in this row, this is going to be our 6-7 pair. Now we've got one of the 6s and 7s in this column, so the other one is going to have to either appear here or here, but we don't know which one, and the 1 is going to appear in one of these 2 cells. And actually, let's start looking at the rest of the columns now and see where the 6s and 7s can go in the entire grid. We've already eliminated certain cells because of the rows. We're going to have an interesting thing going on now with these cells, where each one of these columns has a 6-7 pair in one of these dominoes. And in this column, this 6-7 is going to poke either up into here or down into here. Now, these dominoes, they obviously can't all 3 go to the top or all 3 go to the bottom, because we'd put too many 6s and 7s in that row, in those 2 rows. So we've got 2 of them going up and 1 down, or 2 down and 1 up. And whichever way it is going to influence which way this flip-flops. So I could, for instance, if this is going up, I can only have one of these dominoes be a 6-7 pair, because otherwise it's going to eliminate 6 and 7 from here. And the other 2 have to flop downwards, and vice versa. And you'll notice this always means that there's a 6-7 pair in these 4 cells, and there's a 6-7 pair in these 4 cells. Another way of looking at this is that in these 6 cells, 3 of them are going to be from 6 and 7, simply due to the columns. And one of these is going to be from 6 and 7, also due to the column. So we have 4 6s and 7s in 2 rows. And that means that these 4 cells cannot be 6 or 7, so we can eliminate them from our coloring. So now in these boxes, we have a 6-7 pair here, and a 6-7 pair here. And the puzzle is broken because I forgot to color in this column. Okay, there we go. Now we can do a similar sort of thing that we did in box 5 over here. In this column, the 6-7 is either going here or here. We know that one of these 2 cells is going to be a 6 or 7. This cell is a 6 or 7. So we've accounted for all of the 6s and 7s in this box, and we can eliminate these 4 cells from our coloring. That's going to give us 2 cells now in this column that can be 6 or 7. Once again, we know where the 6s and 7s go in these rows, so I can eliminate this cell and this cell. And now the key question to ask ourselves is how these 4 columns are going to work out. We obviously know that 2 of them are going to have 6-7 pairs up, one of them is going to have a 6-7 pair down, and whichever one is the 1 is going to also pair up with this column. So let's ask ourselves, let's say that this were a 6 or a 7. Which one of these 3 can it coexist with? Well, if this is a 6-7, that makes a pair in the box, so it can't be this one. And if it were this one, then we get an oddagon on 6 and 7s, which if you're not familiar with, we can establish using a basic coloring. If this is green, this is pink, this is green, this is pink, this is also pink. These 2 digits are the same color, they would have to be the same digit, which is not possible. So actually, if this is a 6-7, then it's pairing with this guy. And similarly, if this is a 6-7, then it's pairing with this one. And then the 6s and 7s in the columns are either going here or here. And the important thing about that is that the 6-7s in these rows are either going here and here, or here and here. And you can arrive at the same notion using a couple different colorings of the grid. But the key thing to note is that if this is a 6-7 pair, then the row is broken. If this is a 6, this has to be an 8 because of the 6-8 clue. And if this is a 7, then this has to be a 9 because of the 7-9 clue. So this can't be the 6-7 over here. The 6-7 has to be up here. This has to be the 6-7. And now we can basically just fill them in. That's going to be our 1 because the 1 has to go between the 6 and the 7 in this column. And that is all of the 6s and 7s in the grid fully marked. Now the 8s and 9s are going to become interesting. We know in this row, the 8s and 9s have to go next to their respective 6s and 7s. It could be 8s here and 9s here, or 9s here and 8s here. Either one is possible. We know that there's exactly 1 8 9 in these 2 cells, and exactly 1 8 9 in these 2 cells. And that's going to have an impact on this 8-9 clue over here, because if I try and put an 8-9 pair in these cells, then we're eliminating both options for this to get. So none of these cells can be 8-9, the 8-9 has to go over here, and same issue if I try and put it here, then these cells can't take an 8 or a 9, which they have to. So the 8 and 9 in this row has to go here. That's now finishing off the pair in this box, so none of these cells can be 8 or 9. These are from 2, 3, 4, and 5. And over in this box, these 3 cells are eliminated from being 8 and 9. So one of them is going down here, and the other one is going up here, which is important because that now means this 1, 2 cannot occupy this space. This 1, 2 has to go over here somewhere. So this can't be a 2 for obvious reasons. And the 1 has to appear somewhere in these 3 cells. That's going to place the 1 in this box along with the 8 or a 9, whichever it may be. 2, 3 in this column. Now that we've got an 8, 9 here, there's only 2 places that it can occupy. Both of them require it to take this cell. We've got a 2, 9 pair here and a 2, 9 pair here that are going to interact in interesting ways. Similar to the 6s and 7s, this cell cannot be a 2 or a 9 because we would end up with too many 2s and 9s in the box. So in fact, none of these cells can be 2 or 9. The 2s and 9s in this box must go in these 3 cells. But neither of these can be a 2 because of the 2 3s marked down here. So the 2 in the box has to go here. Now that we've got a 9 here, that's going to resolve our 8, 9 pair. That does now mean that we have an 8 here, which is going to force this to be a 6, this to be a 7, the 7 obviously going with the 9 in this row, so this is a 1, 9 pair. And that's obviously going to resolve all of the 6s and 7s around the grid as well. The next key step in this puzzle is going to come from considering this 2, 3, this 4, 5, this 2, 9, and this 1, 2 together, and the impact they have on this box. So I'm going to start pencil marking some digits we know. This can't be a 1 because 1 is up here in the box. And this can't be a 6, 7, 8, or 9 because they're all over here in the row. So these digits are all from 2, 3, 4, and 5. So now we get an interesting restriction where if this is the 2, 3 pair, this is a 4, 5 pair, and it forces the 4, 5 in this column to go here, because it couldn't go here, we would have too many 4s and 5s in the box. And similarly, if this is our 4, 5 pair, then now we've got all the digits 2, 3, 4, and 5 accounted for, and the 2, 3 pair in this column has to go here. And the key thing to notice here is that this can't be a 4, 5 pair. Because if this is a 4, 5 pair, we've established that the 2, 9 in this column, which can't go in these 3 cells, has to go somewhere down here. But as soon as this is 4, 5, there's no more room allowed for it. And what this means is if I put 2 and 3 in any of these 3 cells, we're completing a 2, 3 pair in the box, forcing this to be a 4, 5, and forcing this to be a 4, 5, and the column is broken. So none of these cells can be 2 or 3. That means the 2, 3 pair in the column has to be these 2 cells. The actual digits allowed for these 3 cells are 1, 4, 5, and 9. And now our 1, 2 pair, because none of these can be 2, has to be a 2 here, 1 here. And these are from 4, 5, or 9. This is no longer a 2. The 2, 3 being down here in this box, this is not a 2. Means that the 2, 3 in this box, the 2 has to go up here. 3 in this box has to go in one of these 2 cells. That's going to be interesting for this 1, 3, which doesn't have much room left for it. It has to go in one of these 4 cells. This can't be a 1, this can't be a 1, so the 1 has to go in one of these 2. And the 3s eliminated from both of these 2 cells mean that this can't be the 1. So this is the 1, and we get a 3 in one of these 2 cells. 3 in this box is then going in one of these 3. Can't go here because of the 2, 3 pair in the column, and it can't go here because I would break the 3, 8. So we actually get 3 in one of these 2 cells, and 3 in one of these 3 cells. Now the 3, 8 has to appear in these 3 cells, so this is going to be a 3 or 8. Looking at the remaining digits for this column, we still need a 4, 5, and 9. That's going to be interesting for this 4, 5, because now I can't put both 4 and 5 in these cells without breaking the box. So the 4 and 5 and the 2 and the 9 have to go here. That means, among other things, this can't be a 3. And these 3 cells have to have a 3, and the other 2 are going to be a 1 and 8. 4, 5, 9 triple to finish the box. 8 is going in one of these 2 cells in box 2. We know that the 9 is going in one of these 2 cells. So this can't be the 9, and also this can't be a 9 in the column. So now if I tried to make this a 4-5 pair, that would cause problems. We know we can't make this the 4-5 pair, so the 4 and the 5 are going up here. That's going to give us a 2-3 pair in the box here. That also gives us the 9 in the box. And this is our 2-9 pair for this column. This 3 is going to help us out with this 1-3 clue. This can now no longer be a 1, because there would be nowhere to get a 3 from. So this is a 9, this is a 1. 1 in this box is in one of these two cells. The 1-3 can still get its 1-3 from here, or from somewhere down here. We need a 5-8 in this column, well that's just placed now. This is a 5-8. The remaining digits, we need a 1, and then these two are going to have to be 3 and 4, it looks like. Remaining digits in the box, we're looking at 2, 5, 8, and 9, which neither of these can be 8. The 8 here is interesting for this 2-9 pair, because if I put a 2-9 here, it immediately gets an 8 next to it because of the 8 in the box, but it should also have a 2 or a 9 next to it because of the 2-9 clue. So this can't be 2 or 9, this is 5 or 8. If this were 2 or 9, once again we get an 8 here, so it would have to extend this way. And this can't be a 9, so if this were a 9 we would get a 2 here, but it can't be a 2. Which means that 2 is going in one of these two cells in the box, and it can't be this one, so it must go down here. This is not a 4. And now within this box, this cell can't be a 9, so 9 is going in one of these two cells. And that, coupled with this 9, is going to serve to eliminate 9 from both of these cells. And the 4 and 9 in this row now only has one place left where it can go. This has to be the 9. This has to be the 4. That makes this a 2. 2 in this box, going in one of these two cells. 4 here, making this a 5. We get 9, 4, 5. That 5 is going to resolve 8, 9, 5. And remember, this 9 needed a 2 next to it. This is now no longer a viable candidate for this 1-3. Neither of these two cells can be a 1, so it's going to have to go down here with a 1 in one of these two cells. Well, it's going to have to be this one because it's the only place for 1 left in the row. 3 down here, that's going to place the 3 in this box. The 2 we just pencil marked. Remaining digits in this row are going to be a 5 and an 8. This digit is a 9. This digit is a 4. That's going to place the 9 in this box. That places the 9 in this box. Remaining digits left here are going to be a 4, 5, and 8. This can't be a 5. This can't be an 8. Remaining digits in this box are going to be a 1 and an 8. That we can do. These two digits are 2 and 4. And we can resolve those. Places the 2 in this box. 8's here and 8's here aligns. We get the 8 in this column, which has to go next to the 3. Last digit in this row is going to be a 5. That now does resolve our 8, 5, which is going to resolve this 4, 8, 5, 8, 4, 5, 4, and left to go in this box we've got a 3, 4, 5, and 8. And that finishes the puzzle.